Thank you for watching this video. So in this video, we're doing question 3 of May, June 2023, question paper mathematics paper 1. And these are exponential functions and parabolas, something like that. So let's go. We'll start with the exponential function. So we are given an exponential function p of x to be that, right? First question, they're asking, is the function p an increasing or decreasing function? 4.1.1.1. If you're looking at this function, is it an increasing function or decreasing function?
A decreasing function.
It's a decreasing function. How do you find that? You imagine a situation where you are increasing your x, right?
Yes.
If your x is getting bigger, what happens to this? So you know very well that this is equal to 1 raised x over 3 raised x, which is, you know what this is. This is 1 over 3 raised x, right?
Yes.
So if x is getting bigger, which is the denominator is getting bigger. So if the denominator is getting bigger, so you're dividing 1 by a bigger and bigger terms, which means now it will become smaller. So your function, which means as you increase your x value, your y value is decreasing,
Yes.
which means your function is
Decreasing.
decreasing. So we're dealing with a decreasing function. We're down to 4.1.1. Go to 4.1.2. What are they saying? Determine p whatever, the inverse of p in the form y is equal to. So they want you to find the inverse of this, right? So how do you get an inverse of function? You reflect about which line? Outline what? Which transformation do you apply? Which line do you reflect by to get an inverse of any function that have an inverse?
Y equals to x.
You reflect about the line y is equal to x, right? What happens? Your x and y coordinate become what?
Y and x.
Y and x. Are you clear?
Yes.
So this is what happens when you reflect about this line. Your x and y coordinates swap around. So you have your function to be y is equal to 1 over 3 all raised what? X. This is your p. Right?
Yes.
So now, if you want the inverse of p, you apply this transformation here, which means your x and y will become y and x, which means your x and y will swap places.
Yes.
Do you understand? So, to get your inverse of p, your x and y will swap places, which means you have your x here, and there you have your 1 over 3. What do you have up there?
Y.
Is y. And then, like a normal function, it should be in the form y is equal to. Y should be the subject of the formula.
Yes.
In a situation where you can make y the subject of the formula, it can be made. You're probably not dealing with a function there. If you're dealing with a function, there should be a way of solving for your y.
Yes.
Okay. But I'm not saying every time when you can solve for y, it is a function. Because there are sometimes, because there are some functions that are 1 to many, right? You can have a function that is 1 to many, but it doesn't have an inverse. But you can always manage to solve for y for a subject as a subject of the formula. So we're solving for y here. We want y to be the subject of the formula.
Yes.
So when you want to remove y up there, you apply the log, right?
Yes.
Apply logs both sides. You can use the normal log or the natural one, but let's use the normal one.
Okay.
So you'll have log x is equal to log 1 over 3 raised y. So when you have a situation like this, if you're logging something and it has the power, right?
Yes.
That power, it always goes to the front.
Okay.
So which means you have log x is equal to y log 1 over 3. Then you divide by log 1 over 3 both sides. Divide by log 1 over 3, divide by log 1 over 3. This and that go away. Not the y, not cancelling the y. The logs go away. So we're left with log 1 over 3, x is equal to y. This is the inverse of P. Are you happy?
Yes.
This is the inverse of what?
Of P.
This is the inverse of P. So let me write it more clearly. So the inverse of P is y is equal to log 1 over 3 base x. Are you clear with that? Then we go to the next question. The next question, they're saying 4.1.3. They're saying, write down the domain of the inverse. Right? They want you to write the domain of this inverse of yours. It is important. The easy way, it's easy if you know or understand the function very well to look what the inverse is, what the inverse should be. But let's suppose that you don't know, right? You know that this is a decreasing function, right? Is it above or below the x-axis? Is this function, this decreasing function, is it above the x-axis or below the x-axis?
It is above it.
It is above the x-axis, right? So, if you are dealing with the functions, this is what happens. So, let's say we have a function here, and its inverse somewhere here. So, let's say we have some sort of a table like this. Do you understand? You apply, so from the function to the inverse, you apply, you reflect about the line y is equal to x, right? So, which means your x and y swap around. Which means your x, your domain and your ranges do swap around as well. Do you understand? Which means your domain of this function will be similar to what?
A range.
It will be similar, not the same. It will be similar to the range. And your range here will be similar to what?
Your domain.
The domain of this function. Are we happy?
Yes.
So, if we look at this function here, what is the domain of this function? Are there any x values that this function is not allowed to use?
No.
It can use all the x values. There are no asymptotes there which can hinder or prohibit or limit our function. So, we can see that our range, our domain, x, an element of real numbers, can be anything then. Or, you can say x, an element of negative infinity to infinity. That is our range domain for the function. Then now, if you want the range of the function, it will be similar to this, except that the range is read on the y-axis, the set of y values that your function is using or allowed to use. So your function, does it have any asymptotes, this function?
No.
Yes.
Oh, it's 0.
It's 0. It does have a horizontal asymptote at y is equal to 0. So will it go below the x-axis, since we can see that it will be positive the whole time? So it will not go below the x-axis. It will only use the x values that are above 0. Do you agree with that?
Yes.
Then now, that will be your range, right? That will be your range of your function. So your range of your function will be, we were not asked the range, but we're just doing it now. The range of a function, which is this, it will be, or let's say function p and your inverse p, whatever. So the range of a function is the set of y values that it is allowed to use. It will be all the y values that are above the x-axis. Do you understand?
Yes.
No, with 0 not included, because that's where our asymptote is. So our range is y is an element
of
0
to positive.
to positive infinity. Or you can say y is an element of positive real numbers. That's positive real number. So which is y is a positive real number. That's how your y values look like. They will be positive real numbers. Then now, let's go to the inverse. So we're saying if you have your range, your domain of the function to be this, the range of the inverse will preserve the similar shape. Are we clear?
Yes.
preserve this similar shape or the similar form because your x and y swap around. So your ranges and domain will also move around as well. So, which means the range of this function would be of your inverse. It would be y is an element of real numbers. Or you can write it as y is an element of negative infinity to positive infinity. Are you happy?
Yes.
So, and the domain now, which is what we were asked in the first place, will preserve the similar shape or similar form. So, but except you read your domain on the x-axis. It's the set of x values that you're allowed to use, which is you're allowed to use all the positive x values. Right?
Yes.
Or you can say x an element
Of
positive real numbers. And you're done. Because now you know that when you had a horizontal asymptote on your real function, then if it swaps around, it becomes x, it will be vertical asymptote, which is what we're excluding there. So you were asked to find the domain of the inverse. Here's the domain of the inverse. But because I wanted to remind you, if you know the properties of the real function, you can transfer them to the properties of the inverse. Are you clear? Let's go. So, go to 4.1.4. That's it. Right. Write down the equation of the asymptote, right, for p of x minus 5. So, p is a function of x minus 5. What does this thing mean? What does this 5 mean? What does it tell you?
0 in an asymptote of the original.
So if you have a function, p of x, and you subtract 5, what does that 5 do to the function? Yeah, the shape, what you're doing with your hand is correct. What does it do?
Yes.
Yeah, it pulls the function down.
Yes.
You're translating the function down. So this is a translation. This function is moved 5 units down. Do you understand?
Yes.
So now if you want the asymptote of this function, you must ask yourself, what is the asymptote of the original function p of x? What was it? So for p of x alone, right, it had asymptote at y is equal to 0. That was p of x. Then now, if p of x is moved 5 units down, what will happen to the asymptote?
It will be minus 5.
It will also shift 5 units down. Yes. So the asymptote of this thing here, entire thing, it will be y is equal to minus 5 because you'll be pulling this one 5 units down. That's what that is. And we're done with this one. 4.1.4. Where we're going? 4.1.5. 4.2 actually. Write down the equations of the asymptote of f. So, how many asymptotes does this function have?
There's 2.
What is the orientations of those asymptotes?
Right?
What is the orientation of those asymptotes? Okay, one is horizontal and the other is?
Oh, it's vertical.
One is vertical. That's the orientation.
Okay.
So what is the equation of the vertical asymptote?
Of the vertical?
Yes.
X is equal to 1.
X equal to 1. What is the orientation for the vertical asymptote, for the horizontal asymptote?
Y equals to 2.
Y is equal to 2. Done. Because for x is equal to 1, this function will not be defined because you have a situation where you're dividing by 0.
Yes.
Do you understand? And now, if your y is equal to 2, which is you have 2 here, you see this 2 and that 2 will cancel. How will you solve x? If x, then you have 0 this side. So how will you be able to solve for x? Yeah, so that's where your asymptotes are. Let's go. You have 4.2.2. What are they saying? They are saying calculate the x-intercept of f Do you understand?
Yes.
They want the x-intercept of f, which means where your graph cuts the x-axis, right? What do you know where your graph cuts the x-axis? Is there any information you have?
Y is equal to 0.
So when your graph cuts the x-axis, you know the value of y at the x-axis. What is it?
Y equals to 0.
Your y is equal to 0, right?
Yes.
So which means for a function f of x is equal to what? It's equal to 4 over x minus 1 plus 2. You know, at the point where you want the x-intercept or x-coordinate, you know the corresponding y value is
0.
So you have 0 here is equal to 4 over x minus 1 plus 2. Are you happy?
Yes.
Then you solve for x. So we multiply by x minus 1, or actually transpose this to the other side. Minus 2 is equal to 4 over x
plus 1 minus 1.
minus 1. Then cross multiply. So minus 2 into x minus 1 is equal to 4. So minus 2x plus 2
Plus 2.
is equal to
4.
4. There, we have 2 minus 4 is equal to 2x, which is minus 2 is equal to 2x. Divide by 2, divide by 2. Your x is equal to minus 1. So this is the x-intercept. If you want the coordinates, it's 1 and
0.
minus 1 and 0. These are your coordinates. I'm not sure if this thing is correct.
It is.
This is correct.
Yes.
Okay. So this is our x-intercept. These are the coordinates. So that's saying use your graph to determine, or sketch the graph of f, label all the asymptotes and the intercepts with the axis, right?
Yes.
They want all the asymptotes and the intercept with the axis, which means what we need now, we need the y-intercept, right? So let's write it under 4.2.3. 4.2.3. We have the x-intercept. We need the y-intercept now.
Yes.
Where our graph cuts the y-axis. What do we know that?
X is equal to 0.
X is equal to 0. So f at 0 is equal to 4 over 0 minus 1, right? Plus 2. Which like f at 0 looks like something like minus 2.
Yes.
So your coordinates are 0 and minus 2. This is your y-intercept. So what we want to do now, we want to plot our graph. So I'll need more space. I'll clean all of 4.1. Then what's left with 4.2.
Yes.
So they want us to sketch the graph. So this is line x equal to 0, right? What is this line? Line y is equal to 0. Right? Label our graph. What do we need to show? The intercepts, right?
Yes.
Actually, we have the asymptote at x equal to 1. And the horizontal one, x equal to, y is equal to 2.
Yes.
Which is this. So, I will plot the asymptotes. Here is the vertical asymptote. Here is the horizontal asymptote going through 2. Are you happy?
Yes.
Okay. So what we need to show are the intercepts with the axis, right?
Yes.
Where does our graph intersect?
At x is equal to minus 1.
X equal to minus 1.
Yes.
Where is x equal to minus 1? Which is here. And where?
At y equals to minus 2.
The y intercepted, y is equal to?
Minus 2.
Y is equal to minus 2, which is somewhere here. Are you happy?
Yes.
So if we plot our graph, is our graph negative or positive?
It is positive.
So we should still use this side and this side of our quadrants. Or if it was negative, it was going to use this side and that side. Are you happy?
Yes.
Okay, let's plot the graph. If we plot the graph, so it looks like this. Oh, sorry. I'll fix that. Here's a minus minus 1 there. This is minus 2, right? This is the vertical asymptote. So to plot it, pass it through here and there. So I'll say something like this. It's not touching the asymptote, right? Does it touch the asymptote?
No.
No, it approaches the asymptote the whole time. Do you understand?
Yes.
Then the other half will be on this side. If you look at this function, is it increasing or decreasing?
It is decreasing.
It is decreasing because as you increase the x value, the y value is going down. Even if you continue this side, increase the x value, the y value goes down. So this function is decreasing all the time. Right? So these are my own questions now, not part of the question paper. 1. Actually, let me say A. So is this function increasing or decreasing?
Decreasing.
Decreasing the whole time. For which x values? X element of real numbers, right? But your x must not be equal to what?
1.
1. Because the function is not defined at x is equal to 1. Because that's where asymptote is.
Yes.
So this is the same as your
domain.
Your domain. So this is your domain where your function is defined. This is your domain. What is your range? Your range. Y is an element of real numbers, but your y
is not equal to 2.
2. So another way you can write it, this thing, you can write, instead of writing r, you can say negative infinity to positive infinity. Then you can say your x and your y must not be equal to 2. If you don't like writing these things here. Are you happy? So now we're plotting the graph. Oh, so we managed to plot the graph.
Yes.
Okay, let me clean that side. I don't know why I left it. So we're left with two questions. Two questions now. So this is the domain of the function, this is the range of this function. So we're going to do 4.2. Go back to the original color, which was black. 4.2.4, right?
Yes.
So they're asking for which values of x, right? Is 4 over x minus 1, right? Greater or equal to minus 2. Do you understand?
Yes.
They're asking, they're saying, use your graph to determine for which values of x, right, is your function greater than what? Oh, is this thing greater than minus 2? Do you see? Okay. So if you look at this, it is similar to our equation, right?
Yeah.
What's the difference?
The greater equals to this part.
This part.
The original equation. It's like this part.
The right hand side, the left hand side,
No, the right hand side.
the right hand side.
Yes.
What's the difference?
There it's 2, then here it's minus 2.
Okay, okay. It's not on the right hand side, they're on the same side there.
Oh, okay.
Yeah. So the only difference, look, it looks like they have transposed this 2 to the other side. Do you understand? So now what you do, you should take this 2 back so that it looks similar to that.
Okay.
Once it looks similar to that, which means it is your graph most.
Okay.
So I transpose this back. So you have 4. This statement is equivalent to what? 4 over x minus 1 plus 2 to be greater or equal to 0. So they want the x values where our function is greater or equal to
0.
So where our graph is?
Positive.
No, greater or equal to.
Oh, greater or equals to 0.
What does that mean? One word for greater or equal to 0? None?
Oh, non-negative.
Non-negative. The word point is non-negative. So our graph is non-negative. This x value is greater or equal to 0 this side.
Yes.
And there as well. Do you agree?
Yes.
So what are the x values? These are the x values. from negative infinity to 1.
To 1.
And after
the vertical asymptote
asymptote
to positive infinity.
To positive infinity. So those x values, you say x in element of negative infinity to
minus 1.
Minus 1. Is it included?
Yes.
Yes. Together with what?
It's a round bracket.
Round bracket.
1
to
positive infinity.
Positive infinity.
Yes.
So someone else will say x must be less or equal to minus 1, or your x should be greater than 1. So it looks like these are the x values.
Okay.
Are you happy?
Yes.
Okay. So with the last question, 4.2.5. What are they saying? Determine the equation of the axis of symmetry of what? Not of f. Of f at x minus 2. Right? They want you to find the axis of symmetry of this function, right?
Yes.
That has a negative gradient. So they want you to find the axis of symmetry of this function. That axis of symmetry should have a negative gradient, which is the m of that gradient is less than 0. Do you understand?
Yes.
What does this thing mean?
It means that the graph is vertically shifted.
That's not vertical. What you're doing with your hands and what you're saying are not consistent.
It's horizontal, sure.
Yes.
This horizontal shift.
Yes. So this is a horizontal shift. How is it shifted? So from f of x was this, right?
Yes.
Now you transformed f to that. What did you do to this to get that?
We shifted f of x way to horizontally, which is 2 units to the right.
Yes. So which means this from this to that. What is this transformation? We shifted f 2 units to the right. Do you understand?
Yes.
Do you understand what you did?
Yes.
Okay. So now from here, as you said, from f to this function, f at x minus 2, you have shifted your function f 2 units to the right. We both agree on that.
Yes.
So now, what do? You can do it the easy way or the hard way. But if you move from f to that, what that means is f of x is equal to 4 over x minus 1 plus 2, right?
Yes.
So if you want f at x minus 2, which is where you see your x, you substitute x minus 2. So you have 4 over x minus 2 minus 1 plus 2. Do you agree?
Yes.
So this is this. This is equal to 4 over x minus 3 plus 2. So your asymptotes meet at what? At 3 and 2. You could have done it the same way. Another way, you could have done the same. Since your function is shifted 2 units to the right, your equation of the asymptote was that x is equal to 1. So you can shift it 3 units to the right, and you 2 units to the right, and your asymptote will be where?
3.
At x equal to 3, which is the same as that. So this is the easy way out. So now, once you have these, what do you need to do now? You need to find the equation of axis of symmetry that have the negative gradient. So how do you do that? Say, okay, if it has the negative gradient, so your m is equal to minus 1. You know that.
Yes.
So y is equal to minus x plus c. It should be in this form.
Yes.
So you know your x is equal to 3 and your y is equal to 2. So 2 is equal to negative 3 plus c. So your c is equal to 5. Therefore, the equation for axis of symmetry will be this, which is y is equal to minus x plus 5. And you're done with this question. Do you have any questions?
No.
Okay. So done with question 4. We'll move to question 5.